Suggestion number 4. Report status dynamically. Now the idea here is that we've got some long-running daemon program which accumulates some sorts of usage statistics that might be of interest. Perhaps it's a server that records details of its interactions with each client, or it builds a routing table or accumulates some sort of usage statistics. So the idea is to install a signal handler that will print this information on demand to aid in debugging. And when I say print, it's more likely I mean write to a file, because the daemon probably doesn't have access to a console terminal. Here's a sketch of the code. This is a program that notionally copies an input tape to an output tape, one block at a time, and generally it just sits there silently doing its job. But if you want to know how much progress it's made, we send it a SIG user1 signal and it tells us. I haven't mentioned SIG user1 before. It's one of a pair of signals that are reserved for user-specified purposes. They have no predefined conventional use. Code is straightforward. Print state info is the signal handler that reports the status information. Suggestion 5. Turn debugging on and off. The idea here is to sprinkle printf or fprintf statements into the code to provide a debug trace and to be able to enable or disable them dynamically. So I'll have a Boolean flag that controls the printf calls, and the flag gets flipped each time a signal is delivered. Here's a sketch of the code. This is the Boolean flag debug on, initially set to be 0 or false. Here's the signal handler. It does a bitwise exclusive OR on the flag, flipping 1 to 0 and 0 to 1. In the main program we install that function as the handler for SIG-HUP signals. That's a rather arbitrary decision to use SIG-HUP there. And then sometime later in the code we do printf statements that are conditional on this debug on flag being set.